So, on our last episode, we were unsuccessful at registering for the iOS developer program, but we might have made it onto the regular Mac developer program. I'm going to be honest, I didn't even check the email because I was kind of irked at things.
Yeah.
In the ultimate scenario, we might actually have a support call live on the show to Apple.
Oh, I hope we do.
I kind of hope we do too, but we're going to save that for another time. So, on this
probably
episode,
not the best idea to do this right now.
So, on this episode, we are going to be working on our game. So, I'm going to open up Unity, make a game now, open, and we're going to open up one of these scripts just so that
MonoDevelop likes to load. Oh, MonoDevelop.
All right, so hit play. So here's what we got so far. You haven't seen this yet.
Oh, whoa!
We got a forward-moving game with like some grass.
There's a thing going on.
And there's a thing going on.
Can you jump?
No, you can't jump.
There is no jump button.
There's no jump.
Well, this is a two-button game, so you shouldn't be able to jump.
Two-button game, yep. And we can move continuously. We can go forever. We can't go forever to the right and left, though. We're still using... so what we're doing on this thing is we're actually pulling the texture towards us. No, we can't because we're flying. We can fly. It's sweet.
That is pretty sweet.
But we're actually going to want to change it so that it's infinite in the left and right directions as well. So that I'm not going to be constraining the player. We're just going to make it so that we'll just keep spawning stuff in front of them.
All right, fair enough.
And so what we did originally actually was kind of cool. We were able to use scripts that we already had from the Space Invaders stuff, like when we were just shooting that thing. We got it all working in this with that. We just used move left and right and move forward, and it was working. What are you
Drinking with Unity.
Drinking with Unity. Oh goodness. That's a whole nother show concept there.
I've got a martini built for two, but you never showed.
All right. So, first things first, let's make it so that we can move infinitely in the left and right directions. So I'm going to create a new script, C# script, and we're going to call it,
C#.
So we have animate texture, emanate texture.
Animate.
This one's animate texture just animates it always. We're going to need to make something that's like a pseudo movement. So I'm going to call this pseudo move left and right.
Pseudo movement. Not like sudo.
Yeah, not like sudo or sudoku or whatever.
Sudo is very different than sudo.
I actually don't know what sudo is.
Sudo is the Unix super user do.
Oh, yeah, super user do. Yeah, sudo.
Sudo.
Yeah. If you're doing command line stuff, you'll know what sudo is. If you're not, we're not going to tell you because
wow, I just went to there, didn't I?
Yeah, you already went to command line. You know command line. Remember, I was a time when you didn't. So
I mean, that's messed up.
It is. It's awesome. So what we're going to be doing is we're going to be moving left and right, kind of.
Is.
So all we're going to do is we're going to actually be attaching this to the object like we did. So we're going to be attaching this to the ground, not to the player.
Cool.
And this is just going to be moving the ground. Oh, shoot.
Oh, shoot, indeed.
Yeah, this will work.
Shouldn't we be really tiling the ground?
This will work. We already are.
We are tiling the ground.
Yeah, it's
so what are we doing currently?
So what we're going to do is we're going to make it so we can move left and right by changing the texture offsets.
Oh, I see.
And so it's going to be just like our animate texture. I'm going to just actually copy this line. You've noticed that most of our scripts are about one line. Isn't that crazy? It's actually not uncommon for me to have a lot of one-line scripts because you can just drag and drop. It's like Lego pieces. It's great.
That is like the opposite of how I script.
Yeah, you like to do the monolithic, don't you?
I do like to do the big scripts.
Yeah.
I don't know why that is, but I do like the big
I know why that is because I used to be a big script guy. But this was also back in the day when just compiling two scripts meant you had to write a whole bunch more stuff because you had to write
like how do you build the windows?
A make file, and you had to write all of this stupid stuff.
How do you build everything that's
and now on Unity, you just put the script in there and it works. So I roll with it. So render.material.main texture offset. This is what we're going to be changing. We're going to only be changing the X component of it. I'm not sure if we can...
guys, it's spelled pseudo.
I'm not sure if we can directly change this.
P-S-U-D-O.
Actually, we don't need to do .x. We'll do vector math. As I said, there will be a vector math crash course probably tomorrow.
Pseudo spelled
right now. You're just going to deal with me. P-S-E-U... Oh, no. It's EU, isn't it?
Yep, it's E-U-D-O.
I said it right, but I definitely typed it wrong.
Pseudo movement? Not pseudo movement.
Oh, that's going to confuse things, isn't it?
Oh.
Yeah, let's try that again.
You have no idea.
P-S-E-U-D-O. Pseudo.
Every time you say that, I think I'm... My first initial and second
Oh, I didn't even
initial
save
PS.
that line. Oh, that's horrible. All right, so we're going to copy that line. We're going to put it back in here.
Bam.
Everything's back to normal. So right now we're doing it plus equals speed times time delta time. On the old texture, we had speed as vector 2. So that means we just need to put a vector 2 to replace this that represents our left and right movement. But we still want to also be able to adjust the speed. So I am actually going to define speed. Public float speed. But this one's going to be a float, not a vector 2.
What's the default going to be? 1?
The default's going to be 1. I like 1 on things.
Yeah, I think 1's a good
work.
default.
The only time that 1's a bad default is when you're doing like physical stuff. A lot of times one unit of force is not enough to do anything. And so I always want to do something that you know has worked. And so 1.0 is great for like just moving something, but if you're doing like force calculations, you might want to do 10 or 50. So render.material.main texture offsets plus equals speed times time delta time. If we just hit compile, I'm just going to save this because I want you to see the compile error we're going to get. So console has our compile error. It says,
Man, YouTube's hard.
Is YouTube really hard? It's not hard.
It's difficult, man.
Maybe it is. Oh, on phone it's horrible. Yeah. Why is this not?
Studio?
Doesn't this usually?
That's awesome.
All right. So, operator plus equals cannot be applied to operands of type Unity Engine Vector 2 and float.
That's unfortunate.
What this means is we are attempting to add to our Vector 2 here, main texture offset,
with the float,
a float, which that doesn't work. And the reason this is a float is because we define speed as a float and time.delta time also as a float. You can find this out by just holding the mouse over it. It says public static float. So we need to have a vector in there.
Not mesh with the float.
So remember when we had move left and right? We're going to go to that. And it has this input axis horizontal. And we also have this vector 3.right. This is the thing that makes it into a vector. Because if you multiply a vector by a float, you get a vector. You get a vector scaled by that float. The left-hand side is called the vector, and the right-hand side is called the scalar, as in it scales things.
That makes sense.
So we're going to just grab this portion here, vector 3.right times input get axis horizontal, and we're just going to paste it right in there. And we're going to put a times at the end of it, or an IU.
An IU works.
And we're going to hit save. And hopefully the compile error will go away.
Will it?
I'm going to wait for it.
Wait for it.
Call is ambiguous between the two following methods or properties. Okay, the reason being is because we're doing vector 3.right. We actually want vector 2.right, if it exists. I'm not even sure if it does.
It's cracking me up. Studio.
It works. Okay, cool. So the reason we had to do that is because this is a vector 2, and so it wants a vector 2 on the right-hand side. We also could have done vector 3.right, and then we could have cast it to a vector 2, but we'll talk about typecasting later.
Oh, casting. I know about casting.
You know about a lot of things.
I work with databases.
Oh, you have to do a lot of casting in databases.
Mm-hmm.
And that's good. Remember actually, you probably don't remember the old days of databases, you didn't. And it just meant that you could just be in horrible situations.
All I know is that floats and varchars do not mix. They are not good bedfellows.
No, they are not. Floats and varchars, I like that. Varchar is something you definitely don't run into in anything except for SQL.
Yeah, SQL is what I work with all day long.
So I just hit play, but that's not going to help us because we didn't attach the script to anything. So we're going to take this quad. We're going to put our move left and right script on it. We're going to go to our main camera, and we're going to disable our move left and right script on it. And we're going to hit play. And hopefully, if we move left and right, it will do something. It looks like it's not doing so good. Oh, wait, it is. It's very slight, though. Is it? Or am I just imagining things? Here, let's check. I don't think I'm imagining things, honestly. I'm imagining things. It was all in my head.
We aren't even moving at all, right? Left and right now. The offset is just going...
Yeah, the offset's not moving left
forward.
and right.
Let's fix it.
That's wild. I swear I'm influencing the movement. But it must be in my head. Alright. So let's look at our quad. So it says...
Oh, I'm refreshing the channel on my phone.
Oh, we put left... Oh, it is moving left and right. It's actually physically moving left and right. We put the wrong script on it. Remove component. Pseudo move left and right. Let's try this again.
That would make more sense.
And we're going to hit play. There we go. That's what I was expecting. Some fast movement left and right. So remember, in this case, 1 is equal to 10 units because of our texture tiling and because of our other things.
We're actually modifying the offset?
Yeah, we're modifying the offset, and now if I hold right, I can just hold right forever, and we will always have forever to go.
That's pretty cool.
If we actually go into the scene, you'll see that we have not moved. It just looks like we're moving because the grass is moving.
So that's the same thing that we're doing with the forwards.
So if you want to test movement as well, you can't, like, if you use arrow keys in this, it's going to do the scene stuff. If you take our game view and move it so that it is a separate window, you can actually click on it, and then you can see how things move in the scene as well. You have to have focus on the game view for it to work. I'm not going to explain why, but there's good reasons.
Reasons.
That being said, I generally don't like to have the scene view and the game view at the same time. Mostly because I don't have enough screen real estate. Actually, there's 2 reasons. Screen real estate is one of them. The other one is I tend to like to use on renderer what is it? It's on became visible and on became invisible. Those functions call when a renderer comes off screen, it basically says I became invisible, and when it goes back on screen, it says I became visible. The problem is it counts the editor camera as
so
one
basically
of these views.
you redefine what is visible and what is invisible because there are 2 cameras active currently.
Yes. So now we got some stuff moving. So now we got to do something. Let's make an obstacle. Let's make an obstacle happen.
Let's do it.
So what's going to be our first obstacle? I think is a cube appropriate, or should it be a cylinder?
Script is disabled. I don't know what that means.
They probably were trying to fix where our problem was.
But we figured it out.
We did. We did it all by ourselves.
Congratulations, us.
All right, so
it's a cylinder.
I'm going to put this cylinder out here. Where's our camera? Our camera's looking at it. So we're going to hit play. And you're going to see there's a cylinder way out there, but it's not moving towards us.
Nope.
It's all sad. And actually, if we move left and right, no matter how much we move left and right, it just continues to strafe with us.
Do you know why?
I think they know why.
I think they know why.
I think
because we aren't actually moving.
Exactly. We're in one space. So what we're going to have to do is we're going to have to make them move instead. And I mentioned on the previous episode we could have the whole thing move. I'm not going to do that because of the aforementioned floating point accuracy problems. So what we're going to do is we're going to take the cylinder and we're going to put some scripts on it. What we're going to give it is we're going to give it the move script that we already have and the move left and right script that we already have. And we're going to make the speed 10 and 10. Actually, we're going to make it 10 and -10. And in theory, if we hit play and move left and right, look, it's moving left and right, although it's moving away from us. Hold on, I needed 2 negatives. We could either put a negative here or a negative here, your choice. If you put them in both places, you've just negated yourself. So we're only going to do one of them. Save, hit play.
Oh, wow.
And here comes our obstacle. It's coming, it's going to hit us. We're going to fly right through this thing. We're going to hit this thing.
Man, I think you're right. This is very Space Harrier-y.
It is. It's going to be awesome. We're going to put a sprite in there too. We're definitely going to put a sprite because we need to do some 2D stuff in here. I want to cover. The goal of this series is to cover a lot of bases.
So we have a question that says, since these episodes are just spitting out everywhere today, I haven't seen the beginning. So what kind of game are we making at the moment? We are making a.
Let me pull up the GDD.
Yeah, let's
pull up the GDD
document.
We're gonna go into Dragfire. We're gonna go into Mega Game Now. Documents. GDD. This is the game we're making. High concept. A third-person object-dodging game using 2 buttons where you avoid obstacles that fly at you from a forward direction in 3 dimensions.
3 dimensions, even though they couldn't.
Story is blank.
Story is irrelevant.
Controls. This game is controlled by pressing 2 buttons or pressing left or right at the side of the screen on mobile platforms. The left button makes the player character move laterally to the left, and the right button makes them move laterally to the right. Obstacles. We have cubes, we have spheres, we have pyramids, we have cones. Actually, we don't have any.
We have cylinders.
Cylinders.
Right
Cylinder.
E-N-D-R.
Is that
correct?
can't be right.
That can't be right.
You gotta be wrong.
I can't spell.
I'm going to copy and paste it from here.
Shame.
Yeah, that was horrible. It's like a calendar.
I can't spell.
Or a colander. But with a Y. All right.
You know what that means?
What?
You don't need to spell the program.
No, you definitely don't need to spell the program. But I'm going to tell you right now, if you can't spell, and you're with a programmer who can spell, he will hate you for the rest of your life. I'm going to tell you that right now. Like I'm gonna tell you, I've downloaded stuff up from the asset store where strength is spelled with a T in the wrong place. I'm sitting here, I'm like, I could fix this, but if I fix it, then I have to fix all of his errors. That
I'm not gonna fix this. I'm not gonna fix this.
So, level variations. Inside of a tube, we might do inside of a tube.
Okay,
that's exciting.
Cool. Tube shooter.
Notes, I'd like to get some 2D elements in this game as well as 3D. Maybe the main character can be a sprite, a la Space Harrier. Space Harrier, by the way, is a game that was made before you were born.
I got my
statistically
GDD.
speaking, we're talking.
I got my GDD from Phoenix University. My folks be proud.
That's awesome.
That is awesome.
Weapons, question mark. I put a question mark because, we don't have a shoot button, but, I like to shoot things sometimes.
I wonder how we could implement a shoot button in there with the
well, I mean,
shoot button.
L Arcade had, boost on, both buttons at the same time.
Can't talk about L Arcade.
I'm talking about L Arcade.
Holy shit.
I don't care. Sony doesn't know about L Arcade. They don't care.
They don't know
that
about
was something that was written off years ago
comments.
so that we didn't have to spend money. All right. So
let's continue with the game.
Continue with the game.
So we have a cylinder coming out.
So let me save this real quick.
Yeah, because
we have cylinder.
DDD.
That's important.
Game
living documents.
Document.
Living documents right here. So we now actually have an obstacle. It moves towards us, and we can move left and right, and we can move left and right infinitely, and the obstacle looks like it's moving with us. But the thing is, it's actually a lie. It's a huge lie. Because the obstacle itself is moving, and the scrolling is moving, but we're staying right in one place.
So what's actually really good about doing it this way is that we keep our floats very tight.
Yeah.
Basically, we aren't going to lose the loss of accuracy by continuing out into the distance.
We've started a project on space exploration, and one of the things that we're going to probably have to do on that is actually base everything on 0. Your plane has to be at 0 at all times.
All the time.
Because otherwise you're not going to have the
you're going to get a drop on
if
accuracy.
you have accuracy problems when you can't see them billions of miles away, no one cares. And so you can move to those if you're moving the origin as well.
But when you theoretically if you were at 11,000 in your Y coordinate, you're going to lose accuracy on your floating point. So, and that will be noticeable once you reach that.
I think we should have a character. So I'm going to make a cube, and he's going to be our hero.
Gonna be
We're going to call him Hero.
It's Hiro. Thank you very much.
Oh,
his name is actually
Hero.
Yeah.
Protagonist.
Yeah. Why? How am I? Where am I on the internet?
All right, Hero Protagonist. We're going to get copyright violations from Snow Crash.
We aren't.
Anyway, so Hero Protagonist, we're going to actually see where he is on the scene. Where are you, Hero?
A power-up that will auto-fire. That's a good idea,
that is a good idea. That is a good idea. That's what we did on Proton Pulse, actually. So
that's true.
So, I'm going to go Hero Protagonist. So where's our camera? Our camera's somewhere here, right? So I want Hero Protagonist to be at 0 on the X, so it's in line with our camera. And we're going to look at the game view, and we're going to move him. See, he should be 0 on the Y. Oh, no. Maybe he should be 0.5 on the Y. We want him to be on the ground. Where is our cylinder? Is our cylinder not on the ground? Oh, it is. It's just that it's a cylinder, so it's two times as big. The default cylinder is taller than 1 unit, just for the record. Even though it's set to 1 scale on all directions, you can clearly see, if we go into the scene view, that the default cylinder, if we put a cube next to it, it's twice as tall. So keep that in mind in your calculations. Also, if you decide to use a plane as opposed to a quad like we did, it is 10 times as big as you'd expect. It is not a 1 unit plane, it is a 10 unit by 10 unit, even though it says 1 by 1 by 1. I'm going to be confusing everyone tonight, but that's okay. Sometimes a little bit of confusion is good for the soul. So, game. We're going to go back to a Hero Protagonist here. We want him at 0.5, so he's on the ground. We're going to move him closer. Is our main camera slightly off? No, it's not. So Hero Protagonist, here he is. So we've already seen a problem here where he's kind of too big. We could make him smaller. That's one way. But I kind of want this to actually look like he's moving through the world. So I'm actually going to move the camera up a little bit. Let's move him up by 2. So now we're twice as high. And we're going to move Hero Protagonist a little bit forward in the Z. There we go. That looks pretty good. 45.
Hero Protagonist.
So, right now if we hit play, and we move left and right, oh wow, it works. You want to know why it works? Because we're not actually moving. I was going to actually parent this guy to the camera, but I don't even have to.
Does the cylinder disappear after it goes behind you? When you have tons of objects coming at you, how does that affect the overall performance of the game?
All right, good question. It does not. It's still there. You can see it. It's just way back there, which is a good thing. You want to know why that's a good thing? Because you don't want a game engine to dictate when your objects disappear.
That is true.
It would make you very unhappy if you were in a first-person shooter and you turned around and everything that was once behind you is gone.
Yeah. You actually want to specify that with your game engine.
Yes.
However,
which we're going to do right now. So we're going to do C# script, destroy on invisible.
Need the fast dogs from Snow Crash.
Yes.
That's fantastic.
That is super fantastic. I still think my favorite part of that book is the first chapter. I know that sounds stupid, but it is. It's just too good. So, destroy on invisible. What this is going to do, this is going to be a really simple script. We don't need start or update.
There's also another suggestion. You could use the object pooling and reuse the object.
I'm going to tell you right now that I'm not going to be doing object pooling on these episodes.
So what I did do in my game back in the day is I actually did spawn every single variation of the object and reuse every single asset. It's unnecessary.
So Phil actually did the good work and actually made it all work that way. Proton Pulse, we spawn and destroy everything. We do not care.
Pretty much do no destroy calls in Robot Alone when I destroy objects. It's actually just
the cost of spawning and destroying things is spawning has a small amount of memory overhead because you bring the object into existence. It's actually not your problem. The problem is when you destroy something, that means that there's memory that's been freed up, which means that the garbage collector, which is a built-in thing, has to go in and collect all the garbage. And so it will occasionally spike your frame rate. If your frame rate's running on the line, this will matter. If you are not running on the line, you're probably not going to notice much of a difference between object pooling and not.
No, the chances are that you're really not going to notice.
On our game's going to be simplistic enough that you're not going to notice object pooling. So we're going to avoid object pooling on this. Object pooling just means that you create the objects. Once you create them, you keep them around. Instead of destroying them, you just reuse the object. You just say, "Hey, you're a new object. Turn on your renderer. You turn your renderer back on. Go back out there. Do your thing." We're not going to be doing that. So, destroy on invisible. So, all this is going to do is we're going to use one of the built-in functions, void on became invisible. I think this is probably a good time to actually talk about where you can find out where all these functions actually are. So let's actually look at that. We're going to search for on became invisible.
On Unity.
Oh, not working. That's the first thing that comes up when you search for it.
Wait, what?
On became invisible, not working.
Oh, that's
It's actually because they had their editor thing up, probably. So this is actually part of mono behavior. And mono behavior has all of the special messages that are called here. So we're very familiar with update and start. These are the ones that are built in. These are all the other special functions that you can call.
There are a lot of them.
There's a lot of them. And on became invisible is one of them, and on became visible is one of them.
I'm going to let you know, if you actually research this list, there's probably a lot of very interesting things you can do with this game.
There's a lot of cool stuff. As a matter of fact, there's been people asking, how do we handle, saving when you are leaving the application or someone calls you when you're on your phone?
That reminds me of...
the on-application focus, pause, and quit functions are your friends.
Yep, that reminds me of when I was implementing Game Center support with the... achievements basically and everything like that. I had to
handle that.
Handle all those things, and there's a lot to take in, but it's really self-explanatory though if you just start looking through this documentation.
Yeah, it's actually pretty well documented too. Occasionally you can run into some stuff that's questionable about the examples, but at the very least the documentation itself usually tells you what's going on. So, on became invisible is one of these, and so we're going to do void on became invisible, and this means if we're off the screen, we're going to destroy ourselves. So destroy game object.
I ain't down with that.
What's wrong?
I don't want to destroy myself.
Well, we're destroying ourselves.
Oh,
we're doing it. It's too late. We've already started. All right. So destroy invisible. We're going to put this on our cylinder. We're going to hit play. And then we're going to fly by it.
I am.
And then, theoretically...
it will be gone.
It's gone. You saw it disappear from the list, and if you go up here, it's gone.
Yeah, you can actually see it delete itself off the hierarchy.
Let's actually point the mouse at it. So we're
you'll
going to look at
notice
the
that
cylinder.
the cylinder's there.
And then...
once it goes off screen,
it's gone.
Boom, it's gone.
Now, there's one problem with actually doing it this way. The problem is, in this game, we could actually do this, and it's gone. And it won't come back if we start moving to the left.
What we could do is actually have a limitation based upon the axis that is on.
Yes.
Currently, and destroy it when it's basically off the terrain.
That's what we're going to do. So I'm going to remove this component. We're going to create another script. C# script. We're going to call this destroy
when off map.
Destroy under Z value.
Okay, that works. Whatever.
So
I wouldn't know what to call it.
Yeah, I don't know. So
it could be called blah.
So right now, if we go to the scene, we look at our cube, we can tell that he is at Z -45, right? So
our cube is at Z -45.
Yeah, our cube is at Z -45, and our camera is at somewhere behind it. Where's our camera? That's more -50. So the camera's at -50. So the moment we're at -51, who cares? So what we're gonna do is public float destroy threshold.
Oh, nice.
I don't know how my brain. Wait, threshold.
Threshold.
I don't like that word anymore because I have to do two H's next to each other. Destroy value.
All right,
equals negative. Let's equate it to
50.
A good default value, which actually is 0 in this case.
Oh, I want it to be 50.
So start. We don't care about start. We can actually delete start. I'm just going to delete it on this one. And update. What we're going to do is if transform dot position dot z if you are in Europe is
less than or equal to -50.
Destroy value.
Destroy value. Yeah, which is going to be -50.
And don't do that. Stop trying to help me, MonoDevelop, because you're terrible at it.
It wants to help you.
It's so bad at it. Look at what it's doing to me.
It's just about as good as Microsoft.
Actually, no. Microsoft's. Have you used Microsoft's compilers? Great. Their autocomplete's amazing. It's like the greatest thing in the world.
Their IntelliSense?
IntelliSense is awesome.
I work with Microsoft every single day of my life.
Okay, fair enough. All right. Do you not like IntelliSense?
Have you ever used Word?
I definitely have used Word, and I avoid Word at all costs.
Man, that program.
All right,
oh,
size.
Man. IE. Do you want me to go into Microsoft?
So all we're going to do is the same thing that we did before, is destroy.
Destroy on blur. Did you see that?
Destroy on blur? Yeah, on blur. All right, so we're going to hit play. So right now we're just going to hit play, and nothing's going to happen because we didn't even attach the script. So I'm going to attach the script, destroy under Z value, to our cylinder. And we're going to watch it, and hopefully if all things go well, it will destroy itself. Yeah, there it goes. It got to 0 and destroyed itself because that was our default value.
We should change it
if
to
we go to
50.
The cylinder and we change this to -50.
No, that's speed.
You're right. -50. All right. So if we hit play on this.
So now it should actually pass
So now it should pass by and then destroy itself immediately after.
So let's keep an eye on the cylinder object in the hierarchy, and it's gone.
There it goes. And if we jump it off the left-hand side of the screen...
It's not actually going to destroy
and then we
itself.
go left again. No, I can't go left fast enough.
But now it's gone.
Now it's gone.
Because it's actually literally behind the character. Yeah. In this case, the character cannot look behind themselves, so it doesn't really matter.
Yep. We're locking the view forward on this one. It's going to be nice and simple. So...
like a space harrier. If you will.
Yes. So let's make it so the player dies if it hits the cylinder. We already have the tools for this. So we're going to take our hero protagonist, and we're going to put...
I don't know why I keep
him?
laughing at that, but I do.
I know why you keep laughing at it.
Because it's silly?
We're going to put Gib on trigger on it, and we're going to make his hitbox a trigger. He's probably going to blow up real early, but we'll find out. And we're going to go to the cylinder, we're going to make it a trigger, and since it's moving, we should probably add a rigid body and make it kinematic. We technically don't have to do that on the hero, because he's not moving, but I'm going to do it anyway, because if we decide to move him later, it'll confuse us when things stop working.
Yes, it will.
So if we hit play, And we're doing this thing, and theoretically, we're probably going to get a null reference exception, actually. Bam! Null reference exception. Or rather, unassigned reference exception.
Object.
So, variable gib of gib on trigger has not been assigned. You probably need to assign the gib. So, we're going to give
that
it
is the equivalent of an object reference not set to an instance of an object.
It is not, because you can actually get those in Unity.
Can you really get the object reference not set to an instance of an object?
You can get the huge ones, yeah. You can get the
because
good
that
ones.
is the most easily explained but obscure error that you can possibly get. Like, it's telling you exactly what's wrong by simultaneously not telling you what's wrong.
So it's funny to me because I've been doing programming for a long time, and I hear people complain about errors and stuff.
Oh, errors don't bother me.
And they're so great because when I was growing up, we got syntax error.
Yeah.
That's what we got. You got a syntax error.
Oh,
There's something wrong with your syntax.
Your syntax is
all messed up.
But no, object reference not sent to an instance of an object just means there's a null value somewhere, and you need to figure out where that is.
All right, so what we want to do is we want to just go to our hero protagonist. So we got this gib, and it's set to none. That's our problem. So we're going to give it explode.
We're going to give it explode?
Give it explode. And then we're going to move forward, and bam, that's game over.
Oh, nice.
Kind of, except for we're still moving through space. That's actually kind of cool. We could put the game over on the screen, and it'll look nice. So.
And it'll do the Gradius music or whatever.
It'll
be so happy. It'll be like, you died, you messed up, good job, game over.
Or we could do the Space
Game
Harrier.
over,
Hold on. Are you ready for this, Space Harrier?
This is the Space Harrier one.
Ah! Get ready.
Yeah, that is true. You know what my favorite game over is, though? Sega Rally.
Oh, there's nothing better than Sega Rally.
Game over, yeah!
Exactly. Except for they extend that, about 10 more seconds than you did.
Yeah, they do. I can't do it that long. I'm sorry.
All right, so we've got...
I apologize.
We've kind of got a game over condition.
Sega Rally.
This is crazy. We're 5 episodes in, and we've got a game over, kind of. So that's insane. Like, usually we don't do game over until way later.
So I guess... need to... Let's set some procedurally generated cylinders.
All right. We're gonna get this. We're gonna get this game started. So right now we've got a single cylinder. I'm gonna go ahead and make a prefab of the cylinder. I'm not even gonna rename it. We're just gonna call it a cylinder because that's what it is.
We should actually make them a lot taller and make them pillars.
All right, pillar.
Let's make them substantially taller.
We'll see how it looks. I'm gonna bring it in the scene. There, got a pillar.
All right, I can dig it.
You like that?
Is it? It should probably be offset more, though, shouldn't it?
Yeah, we can make it taller.
So that we can make it taller.
We can go...
what?
What was I adjusting?
What?
Oh, maybe... What? Oh, that's the prefab.
Oh. Much better. So we need to make it so it's actually getting the maximum potential of the pillar.
So the maximum potential is at 10 because on a normal game object it would be at 5, but
since we
cylinders are double because they're double for some reason. So we hit play and we have a cylinder and it should still work, and now it's all like pillared out. All right, it's called a pillar.
You know what else we could do?
What?
We could do the Space Harrier ground is on top of the world thing.
Yeah, we could, but that's another level.
That's in the future.
4.
That's in the future.
Yeah.
The future Conan. So let's get some procedurally generated pillars.
All right, so we're going to delete this pillar. We don't want it anymore.
Oh, more comments.
And we're going to hit save.
Needs an upgrade store with power-ups or consumables like take an extra object.
I refuse.
Etc. No.
I refuse.
Very cool. I like it. You lose and win at the same time. Yeah.
Like that too.
Game over. Yeah.
Careful. Copyrights. No, I'm kidding. That being said,
game over. Ahoy!
I actually did a test video briefly, and I was running Mega Man music, and it totally knew it was Mega Man, but the people who claimed it were totally not Capcom.
Oh, nice.
All right, so what we're going to do is
I will continue to read the comments.
C# script. We're going to call this
procedurally
randomly spawn.
Random pillars. Oh,
no, because it might not be pillars; it might be other things.
I like random pillars.
Remember, we got to be general about these things so we can use them for other things, because we don't want to have to write a script that's called random pillars, random cubes,
random gobbledygook.
We could, but I'm not going to.
Okay.
All right. So, randomly spawn.
I'm sorry. Maybe a little bit different dynamic tonight than normal.
Yeah, it's exciting, though. We're learning new things about ourselves and about the world. All right, so public. We're going to need some variables. Give us some variables.
Foo.
No. Like useful ones. Give me some useful variables. What's a useful variable for spawning? X? Are you kidding me? That's the best you got? X?
Yes.
All right, I'm done. I'm done asking you things. All right, float.
Horizontal position.
Horizontal.
Or the horizontal threshold.
Minimum horizontal. Actually, let's do min. Horizontal position.
No, just horizontal. That's too much words.
Okay.
And then max horizontal.
Fill horizontal.
No, god damn it, no.
All right, max horizontal.
Yeah. And then min vertical, max vertical. Oh, but we won't really need verticals.
Yeah,
but right now we
can
could set them as a 0 right now.
Yeah,
so we can make this
float,
generic.
Min vertical. Public float max vertical. I'd say the most important thing is public game object thingy.
Okay, here's another thing. How many spawned objects we have?
Negative 10.0f.
By the way.
Oh,
how many spawned
how
objects?
about rate of spawn? Not necessarily.
That's fine.
Yeah, so let's do min horizontal, negative 10, max horizontal, positive 10. Remember, meaningful values are better for you because then you know things are working.
Currently, we're going to use 0 and 0 for vertical, right? For this one.
I'm going to just let it be negative 10 and 10 so that we know that things are wrong.
Adjust it.
Yeah. We know that it's working then. So public.
Ooh, another comment.
Float.
So much
min
random.
Spawn time equals. Let's see. Let's do 1.0 f.
Oh.
Public float max spawn time equals 1.0 f. We can do that where it'll just be
negative 1.
No, it's
just a 1 and
it's
a
just
1.
always. It just will always spawn in 1 second.
That seems really.
It's good for a default value, I think, because you know that it's working, and you know, and it's consistent. It's nice, and you can make it inconsistent, and then you know that it's working. What? He's giving me a face. You'll never see it on the screen, but he's giving me a face.
Yeah, most of you don't even see my face.
No, they don't even see my face, right? Or hopefully they don't. Oh, thank goodness.
Oh, time. That would have been amazing.
Oh, episode like 2 or something, I did that once. It was horrible. It was just awful. All right,
just like, here's my face while I'm programming.
All right, so all we're going to do is, we're going to use some new functions that we haven't seen before. So in start, we're going to do invoke.
We haven't seen them before?
Well, we've seen them before on the show, but we haven't seen them on this miniseries.
Oh, I see.
We've definitely seen them before. We've seen them so many
I've
times
never
before.
seen this.
All right, so we're going to invoke the function
sorry.
spawn. Now I'm going to call it spawn now.
Than I need to be.
And the time is going to be random.range, and the range is going to be min spawn time.
Y'all should
and
comment because
max
commenting's fun.
Spawn time. Right. So what this means is invokes a function. We're going to invoke the function named spawn now,
which we do not have.
And it's going to happen. Normally, you could say like 1 here. If you just said 1.0f here, it would spawn in 1 second, right?
But it's going to be a range between.
But we want a range between our minimum and maximum.
Time.
In this case, it actually will still be 1,
no matter
because that's what our defaults are. But if we change them in the editor, it won't be that way. So
random.range is great.
I love random. The whole random section is great. Look at it; it's actually great. Let's do
random.range is fantastic.
Sometimes if you want to learn things, just type things and then just put a dot and then see what's in there. So like random dot inside unit circles.
It'll always take you what kind. It'll always tell you what kind of object it needs.
This gives you a vector 2 that is somewhere in a unit circle, which is great. So that means if you want a 2-dimensional random direction, you've got it. Inside unit sphere. 3-dimensional random direction, you've got it. On unit sphere, 3-dimensional normalized random direction, you've got it. Rotation, I didn't even know they had that. That's sweet. You can just really have a random rotation. Have we used that before?
No,
we
never.
Didn't even know. And then we got seed, which doesn't make any sense to anyone unless you know what random means.
Oh, a random seed?
Yeah, you can change the seed.
Sweet.
Yeah. it's not going to mean much in this game. So
hey, random seeds mean a lot.
I don't know what a uniform is. Oh, uniform. I guess that's a more uniform version.
What's fascinating to me about random seeds, and probably to anyone out there actually, is random seeds. You can actually determine the random.
So yeah.
So like you could basically in a multiplayer game actually have it mean the same thing for everyone by determining the seed.
If you have played Minecraft, you probably know about this actually, because if you go into the advanced settings on Minecraft, you can actually set a number to determine the world. And that world is generated from that number. And how does it do it? It's actually the seed for the random number generator.
And basically what someone would do is send out that seed, and so everyone is on the same world.
Exactly.
The same exact generated planet because the seed is exactly the same. It's actually fascinating.
We're going to get rid of update, and we're going to replace it with void spawn now.
You all should think about that in regards to multiplayer games. It's pretty amazing.
And what we're going to spawn is we're going to instantiate thingy.
How do you make sure your procedurally generated thingy isn't impossible to pass, but gets more challenging the longer you play?
That is called game design.
That is game design,
and we're going to be playing with it a lot. I actually estimate, depending because of the type of game we're making, I estimate we're going to spend more time tweaking things than we are making the game. Like, that's generally how it goes with this type of game. You know what I'm talking about.
Stop talking about my.
Go for it. Talk about your game. Dude.
So,
your game's not stupid. Your game's awesome.
As you progress through the score of my game, more of these little bombs appear basically randomly as it's going along, and the higher you get in your level progression determines how many of these things spawn. So that was my game design, is determining the amount that it takes, the threshold, the percentage that it actually takes to get into the next level.
Why does it keep
it's hard to get that kind of flow going, though.
So we want transform dot position. So I'm still using transform dot position in this because what we're going to do is we're going to actually spawn this in an area around a position, and that position is going to be defined by wherever we put this script on. So we're going to do transform dot position for the base, but then we're going to offset it. We're going to do not plus equals in this case, because that will do some really fascinating stuff.
Yeah, very fascinating.
So transform position plus, and we're going to actually use some new stuff that we haven't done before on this mini-series. Again, this is pretty normal for everyone else who's been doing this for a while. So new vector 3, and we are going to define this vector 3 as, so the x and the y we're going to affect by min horizontal and max horizontal. So it's going to be, so new vector 3 has 3 constructors,
x, y, and
z. X, y, and xy, and x, y, and z. We actually only want x and y, so we don't even care. Well, yeah, we don't care about z. So we'll just do the two one.
Do we not care about z?
We actually don't, because 0 plus the position will work just great. Yeah. So new vector 3, and we're going to do random.range again.
No one cares about me.
Min horizontal.
Coach Z.
Max horizontal. And then comma, and then we're going to do random.range again. I'm just going to copy and paste this. Copy pasta.
It's going to be between min horizontal and max horizontal.
And min vertical.
Vertical shouldn't even be taken into account in this one.
Why not?
Because we aren't actually going to be.
We're not going to be doing it, but this is in general. Although we probably should have had a Z in there if we're going to do it in general, but whatever. All right,
the amount of objects.
Look at all those. Look at all those parentheses we have to put at the end. So this parenthesis closes this thing, random.range. This one closes the vector 3, and this one closes the instantiate call.
Is the amount of objects you avoid determined when you go to the next level, or is it time based? Like survived avoiding obstacles for X amount of time.
Well, we're not sure if we're going to be doing levels yet. We probably will.
I would think
it's probably going to be a combination of the two, honestly. It's probably going to be, during the level, it's going to get more crazy, and then we're going to have level variations like tubes and things on the top and bottom. And,
or we bring the ground on top. Yeah, like Space Harrier.
Yeah, like Space Harrier. Why not? All right. So we're going to hit
some Space Harrier.
We're going to hit save. We're going to see if this compiles. It probably doesn't. Oh, it doesn't. Look. All right. No overload method instantiate takes 2 arguments. We forgot a third argument, and that is we need a rotation. We're going to go with quaternion dot identity because we don't care.
Hey, There's nothing I remember. It's that quaternion.identity means.
So we've got this randomly spawn thing. So we're going to create a new game object. I'm going to create a... It's not actually in here. For some reason, new game object's not in this list. But if you go into game object, create empty, it's in the list. So you go here, and you've got this game object, and we're going to call this pillar spawner.
Is the thing about Unity that bothers me the most is that new empty game object is not there.
Yeah, it was up there. It actually might be the thing that bothers me the most too, because quad was actually highest on my list originally.
I know, and
they added a quad, and now we have to complain about that. So
new empty game object.
So we've got this. We've got this game object. It's an empty game object, so you can't actually see it. You can just see the handles for it. If you look outside here, it's like gone. You can't even click it. So if you click on it, it's going to be called pillar spawner. You can see it, and it's in the world. We could actually add some scripting to make this visible. I'm not going to do this just yet. Maybe we'll do it on this episode, but we'll see.
Let's not worry about this.
But what we're going to do is we're going to put randomly spawn on here. And so we're going to click on our pillar spawner again. And so now it has randomly spawn. And we're going to give it a... we're going to give it a game object. We're going to give it the pillar. We're going to hit play and see what happens. 1 second. 1 second. Okay, so it only did one. And the reason it only did one is because we did an invoke call. So there's an invoke repeating, which would also serve us quite well because it would continue to repeat. But I actually prefer to use invoke and then do invoke again on the function itself. And the reason being is if you tweak these values while the game's running, if you just do invoke repeating on start, it won't be tweakable. You can't tweak the value after that. But if you do invoke at the end of spawn and you just invoke it each time,
because every time
it invokes, it checks to see what the new random value should be.
But a start will only happen at the very beginning of the program.
Yes. So spawn now, comma, and the time will be exactly the same. It's really exactly this call, so I'm just going to copy and paste it. Bam. Save. So now if we hit play, 1001. 1002, 1003, 1004, 1005. You'll see that the pillars are actually different sizes. That's actually not true. They're just different heights. As you can see, there's some that are floating in the air.
Yeah, they shouldn't have any vertical range on them currently.
Yeah. Bam.
So we can actually change that, though.
So we can change that.
And not in the script. We can change that.
Yeah, we can change that right here. We can just do mid vertical 0, max vertical 0, hit play.
Now they will always be a consistent vertical.
Yes. Now, the vertical is actually based on where the object is, so it happens to work in this case because they're gigantic, but it would probably look like they were floating if we had made them smaller.
So what we need to do is actually get these things spawning out farther.
So we're going to put this... All we have to do to change that is just move where this object is. So we're going to put it way off at the end of our plane here.
What's the actual point? Put it at 50.
50, all right. And we're going to put it at Y of 10.
10?
Because they're 10 high, right?
Yeah, I guess.
So if we hit play, we'll get full-size pillars. They do kind of look like they're just coming in because they're so freakishly huge.
They really are. You know, what we could do, actually, is depending on their distance, we could actually make them grow and look like they're in the distance. So we could start them out as like a zero scale and then increase them as they come towards us.
Totally do that.
I actually think that would look really cool. Why don't we try that?
Should we do that right now?
Sure.
Is that what we want to do?
Why not?
We want to spend our time scaling some things?
Sure.
All right, cool.
Do you think that's a problem? I don't think that's a problem. I think we should actually expand their Y coordinate as well, so it's more than just 10, so we get a longer range of them.
So what we're going to do is we're going to say...
scale.
Scale over time.
Yeah, scale over time. Perfect. So
and
I'm very excited.
Actually, before we do this, I'm going to save this. I'm going to save scene, save project. We're going to submit what we've got to Git.
Oh, good call.
What is it called? Source tree. There we go. So we're going to go to our working copy. We've done a lot of stuff. Wow.
We actually have done quite a lot.
Drag all this stuff in. We're going to commit. We're going to hit
pillars.
A lot. Pillars.
Stuff.
I'm drunk.
Whoa. I'm not that dumb.
I'm drunk. All right. So, and I forgot to. That's how drunk I am. I forgot to say.
More comments.
So if you commit and it's not actually sent to the repo, what you want to hit, you'll see this one next to it. You want to push that to the repo. Normally, we just set it to automatically push.
If there is any score add later down the road, can you folks set it up so we can save the score? So if the game was to quit and then restart, it would retain the score.
Absolutely. We're probably going to have some online scores by the end of this. So
I've done that.
Yeah. It's hell, isn't it?
It's not too terrible, but there's a lot.
But we have to support all the platforms.
A lot more things to it than you would expect.
All the platforms.
I have only shipped on Apple.
We have to support BlackBerry.
Oh. I'm done with this conversation.
We don't even have to test it. We're going to blindly release something on BlackBerry. We're not even going to test it. It's going to be great. It's going to be a blind release. It wouldn't be my first blind release.
Apparently,
that would be
Robot
Captain's
Alone
log.
Needs some
Captain's
sort of
blog,
update.
rather.
Robot Alone needs some sort of update.
It probably does.
If that is possible, that would be great. Yeah, I'm sure it does need some sort of update. I haven't touched that game for a while. Oh, going into old code is not a fun experience.
All right, so
I'll think about it.
For scale over time, what we're going to do is, let's make this fancy. We're going to do a public vector 3.
Not a vector 3, right?
Final scale.
Not a vector 3?
No, not a vector 3. And
I
actually,
still uses
we're going to create a private
vector 3.
Vector 3. Doug should use vectors. That would be awesome.
All the time.
That would be so sweet. We have a friend named Dr. Beck, so...
I always think that he should be using variables called vector 3s.
So private vector 3, and we're going to call this initial scale. And our final scale, let's default it to... What's the appropriate one for this?
1.
But 1 is like
one
most
is a normal scale.
already.
No, it's perfect because you don't necessarily want things to scale.
Yeah, but the thing is, you want it to be obvious when it's working, and if most objects are 1, you want it to be something that's not 1. So you either want it to be 0 or something higher than 1. What do you want? 0? Okay. So we'll have it scale away. So
equals 0.
Equals vector 3 dot 0. If you just do 0, it'll be like
It'll be like that is a float. That is
what are
not
you doing?
at all a vector 3.
All right, so in our start function, we're actually going to use our start function. This is actually kind of rare. We're going to say initial scale equals transform dot scale, local scale. That's what we're going to do. So now we're storing the scale that the object currently has in initial scale. That way we know what it is so that we can do something with it. And what we're going to do is we're going to do something that we haven't done yet either on this miniseries. This is, again, a crash course. We're just going to show you all of this stuff. There's a lot of information here that you should be Googling and looking at things. You should learn this stuff. This is not hard to learn, but we're just glossing over all of it so that you have tools to work with.
Well, first of all, this guy wants some Android 11.
Oh, we're going to get Android 11. As a matter of fact,
assuming for Robot Alone at some point.
For Robot Alone. Okay.
One of those 4 BlackBerry users is going to be furious when this game fails to launch. That's another comment that we have. That's amazing.
Wow.
That is amazing.
Is one of them Obama?
Probably. Probably.
The Crackberry. All right, so... what we're going to do is we're going to launch a coroutine. We're going to do start coroutine, and we're going to call the coroutine scale.
God, I love coroutines.
We'll just call it scale. Coroutines are magic.
Oh, they are. They're so
Though
good.
I do kind of wish that they were actually threaded. Like, that would be super awesome.
Multi-threaded
but they're not. They're not
coroutines?
multi-threaded.
That would be amazing.
Currently, they just run on the main thread.
Screw BlackBerry, just release it for QNX. That would have a better chance that way.
Engage for life. Side talking, yo.
Taco phone.
All right, so...
Side talking. Really? Are we going there?
Yeah. So, initial scale, transfer to local scale, start coroutine scale. We aren't going to be using update. We're going to make a function called scale. And it's not going to be a void. This one's actually going to return a value, although it's a magical, ugly value that no one ever really knows what it is. Actually, it's not that
An
difficult.
IEnumerator?
It's an IEnumerator. I feel bad that we have not shown people on this mini-series how to make their own function, and yet we're now doing a function that returns an IEnumerator to confuse them. I know. All right, so this is a crash course in coroutines. So what this is going to do is we're going to we already have our initial scale figured out. We have our final scale figured out. We need a time variable, so we're going to create a float t equals 0.0f. Yes, you can define variables in the middle of a function too. You don't have
can
to do it at
define
the
variables
beginning.
whenever you want to.
Yeah,
it's just all
beautiful.
a matter of scope.
Yes, so like this variable only exists within this function.
This function call, one specific function call.
Well, actually,
right?
in an enumerator, it's a little bit different because it comes back to it. Remember?
Oh, yeah, that's true because it actually.
Yeah.
But if this was in like an update call,
if this was an update call, it would just be
only be in that
0,
one instance of update.
It would be a 0 at the start, and then whatever we did with it, and then it would be 0 at the beginning again. But it's not going to be that case because this is a coroutine, and these are magic. So,
God, aren't they?
We're going to do while.
So
this is a while loop. Welcome to while. While t is less than a value that we have not defined yet, we're going to do public float time equals 1.0f.
Or we could do a distance too.
And we're going to do time. We're going to do this based scale over time. Read the words.
I know.
We'll do a distance somewhere else. We might actually want to switch it to distance, yes, but we're going to just do this right now as a hack. And we don't want uppercase time. We want our lowercase time, which is different. It's our own variable, not the one that's not a class that's
built in.
It's built in. All right. So while t is less than or equal to time, we'll give it that.
All right.
I don't know which is more appropriate. It's less than a moment anyway, so who cares? While t is less than or equal to time. So I always forget this, so I'm going to do it right now. T plus equals time. Capital time this time. Delta time. So this way, it's actually a timer. Otherwise, I forget, and it gets in here. It's like I'm going to just do this forever because
you're never actually
iterating
upon your time.
So we're going to do that at the end, and then the other thing we're going to do at the end is yield return null. This is a coroutine thing. If you do this, it means stop here, and then start on the next line. The next time you come in the next frame. So.
I think that's appropriate, right? That's the correct terminology of frame.
Yeah, frame is the frame
because
is appropriate on this.
Will actually go every single
locked,
frame.
are frame locked. Yes. So, and then we're going to do something with our scale. So what we're going to do is we're going to use another function that we haven't seen before. We're going to do vector3 dot lerp. This means linear interpolate. That's what it stands for.
It's
lerp.
Not like a slurp, which is a spherical linear interpolation.
Yes. So a lerp is going to be it's taken as a from vector. We're going to use initial scale. A to vector, which is going to be our final scale, and it takes a time, a t, rather,
which would actually be t in this case.
It's not t in this case. It's
not?
close. This is close. It's close, but no cigar. T will work in the 1.0 case. It will absolutely work if your time is set to 1.0. But if your time is set to greater than 1.0, at 1 second the scaling will be done,
and
the coroutine will still be running. And it'll run like another 3 seconds because it'll be like we haven't reached time. What we actually want is we want t divided by time. Because this is a percentage
that makes
through
sense.
the time.
That makes sense. Sorry.
No worries.
Not as sharp as I usually am.
No, you're fine. You're fine. No, don't even worry about it. And then after all of this, once we're done with this, we want to make sure that it is actually in the final scale. So we're going to set...
Actually, shouldn't we be setting our transform scale in the while
So this
loop?
doesn't do anything.
It's just counting, right?
It's just counting. It just counts, and this lerp thing is just like, I'm returning a value, and you're not doing anything with it, and I don't care.
So why don't we set it after time.delta time, or t equals time.delta time? Do we need to set it before or after?
It actually doesn't matter. Well, it matters by like one frame. Who cares? I think
we should.
This is the right way.
I think we should set it after.
We are setting it after. Oh, we should set. No. We should definitely set the time after.
Matter.
Set the time after. So
I'm
transform
confused.
dot.
There are no more comments.
Transform dot position equals vector3 dot lerp. So what this means is lerp returns a linear interpolation. So if time is 0.5, it'll return the point between initial scale and final scale. Take note. This is actually one of the most efficient ways to get a midpoint between 2 points.
Yes, this is actually.
So we're going to go down here and we're going to do finally transform dot position equals final scale. Oh wait, not position. Scale, local scale. We're not doing position. We're doing
actually?
scale.
So we're setting that scale,
scale,
right?
Yeah, we just did. See, we just did it. We just set it there and we set it there.
Fantastic.
So we're gonna hit save. And we're gonna put this on our pillar.
Pillars. Yeah.
So we're gonna put this on our pillars. We're gonna hit play.
So theoretically, we're gonna see these pillars rise up out of.
Yep.
Okay, it's kind of doing everything opposite.
Well, it's doing what we just told it to do. It says scale down to 0.
Well, let's fix it and make it scale from 0 to 1.
All right, sounds good. Well, to 1 because do we want it to be 1?
And we should really only be scaling the y-axis in this case, but that doesn't matter.
So we're going to go to pillar, and we're going to do scale over time, and we want the final scale to be
1, 1, and 1.
No, we want it to be 1. How big do we have them right now?
I think 1, 1, and 1.
We have them 1, 10, and 1.
1, 10, and 1.
So we want 1, 10, and 1.
Why didn't we set the initial scale?
And we set the initial scale to 0, 0, 0 because we don't need to. We just use the base scale. So
let's go ahead and do it.
So now if you hit play,
theoretically these things should be.
You'll see that they're coming. Kind of. Actually, it looks really cool. But
it does look kind of cool, but that
is exactly what we want, right?
No, we want them to kind of appear out of the ground like they're coming in from the distance.
So the way we're going to fix that is we don't actually have to do any scripting to fix that. So let's actually save project and just check this in real quick.
Oh, more comments.
Commit.
Sorry, I was looking at the Unity doc for BlackBerry. Not much to read there.
Not much to read there. All right.
Is there a Unity doc for BlackBerry, really?
Yeah.
Unity supports BlackBerry?
I wasn't joking. Build settings. BlackBerry.
Oh, there is a
it's
BlackBerry.
Right there. Anything that's not grayed out here, we're publishing.
Wow, that's amazing.
I don't even care that I'm giving BlackBerry money. I don't even care.
That's great.
I should care, but I don't.
You shouldn't care.
All right.
That's amazing. I'm so happy that they can release on BlackBerry.
All right, so what we want to do is we want these to scale out of the ground. So what we're going to do is we're going to bring our pillar back into the scene to work on it a little bit. So let's bring it so that...
Whoa.
Why is... Oh, this scale's 0. Let's just make it 1, 1, 1 for right now so that we know that it's there. There's our scale. There's our pillar. So what we want to do is we want to actually create a new empty game object. So what happens is if you scale something, it scales from the center, right?
It does.
But you can parent game objects in such a way to change the way that their scaling behavior works. So if we create a parent game object called, I'm going to call it pillar parent for right now.
I think that's fantastic.
And we're going to put pillar in there. So
we're going to offset that object, right?
Yeah. So I'm going to put these at 0, 0, 0 in all cases right now, just so that we can see what's going on here. And 0, 0, 0. So we're at world origin. Is at 0. I'm going to look at without the ground there so you can see this there. So pillar parent is here. If we move pillar up, separate of its parent,
to 1, right?
We're going to actually move it exactly to 1, yes.
Because a pillar is actually 2
And then
units.
we scale the parent. You'll see that it now scales from the bottom. And this is because if you click on here, you'll get the pivot point, and you'll see that we've moved the pivot point because this is not in the center anymore. It's now underneath.
Yeah, parenting things is fascinating.
And so you can use that to do little scaling effects like this. So we're going to do that. And
the pillars look like the old arcade Star Wars when they were coming into play.
Yes,
cool.
It does. Oh, I love Vector Star. I love Vector Star Wars. Though they had triangles because they didn't have enough polygons for pillars.
Yeah, pillars are expensive.
Yes, they are. So pillar parent. So I'm going to actually just create the prefab on this, and we're just going to. Who cares? I'm going to delete the old pillar. You don't want it anymore.
But
you're not wanted.
Old pillar. I didn't.
I like this one a lot better because we can even have. We now can put the pillar spawner at 0, and it will work properly because now the feet of this thing is on the ground.
Yes,
which is awesome. And actually, if you're making characters, this is how you want to set the characters up because you always want their pivot point to be on the ground so that you know when they're on the ground. So so we got this. We're going to change this though. We're not going to have scale over time here. We're going to copy component, and we're going to paste component as new here. And we're going to go over pillar. We're going to get rid of the scale over time on here. Remove component.
What about the destroy and move?
And we're going to leave this at 1, 1, 1, and we're going to make pillar parent 0. Sorry, actually, we're going to make it 1, 0, 1. Yeah, that'll be perfect.
So it's actually just squished right now.
Yep.
Which is perfect.
And so now, if we apply this to our prefab, so this means that the prefab is the same. Because remember, you can change things separately of the prefabs.
They just look like a hole in the ground now.
We're going to delete. And we're going to go to our pillar spawner, and it says missing because we deleted our old one. We're going to put pillar parent on here. And we're going to hit play.
So theoretically, we should just see them. Oh, that's sweet. Look
And,
at that. That looks kind of cool.
It does. And you want it wider, right? So let's make the horizontal like 20. Actually,
25.
let's make it 50.
Okay, 50 is good.
And 50.
So now they should be spawning everywhere that they could potentially be. That's pretty sweet.
And then let's actually make it so there's some randomness here. Let's make it so it's like 0.1 to 2. All right.
Can we make the frequency of spawning a little bit more? Oh, that would be the
that is the frequency of spawning. So you want it to be 1?
Yeah, let's make it faster.
Let's actually make it like 0.0 and 0.5.
So now we should see a bunch of these pop up. Oh, that looks cool. That actually does look really cool. What do you think of this?
I think it's awesome. I love making games.
Making games is cool.
Cool.
Well, I think that's a good stopping point.
Yeah, this is an excellent stopping point. We're going to save. We're going to save project.
So, thanks for putting up with
put all this stuff here.
the somewhat drunken shenanigans.
Yep. Commit, and we're going to call this push commits immediately.
Pillars look like
we've kind of got a game.
Kind of got a game. Look at autocorrected view.
Yeah, it's crazy like that.
Computers are weird.
All right. Well, thank you for watching.
Yeah.
What does it do? Okay.
Oh God, what's
all right?
happening?
Faces on.
Oh, face.
All right, faces on. Thank you for joining us tonight. If you have any questions, please email me pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE.
If you want my nonsense, you can follow me at Magma Lemur on Twitter.
Yes, you should buy Phil's game, Robot Alone.
Yeah, you should.
But if you only have $1, I don't care about his game. Put it on the Kickstarter.
Yeah, donate to Vanguard V.
Yes,
seriously,
please.
Right now, donate.
It's going to be awesome. It's going to be so awesome.
Right now,
so
donate.
Great.
It's so good.
And thank you very much. And we'll catch you tomorrow at 6:30 for another set of 3 episodes.
I may or may not
about
be
the same
here for
time.
any of them.
So,
I do not know.
All right, yeah, we'll see. We'll see. It is programming night tomorrow, but I think I'm going to have to skip. So
you die. It zooms out. Turns out you're in Max's beard. That's fantastic.
Thanks for joining us. See you later.
Yeah. See you later. Have a good night.
And now it's banter time.